Good evening, friends. Let us talk about the lift chart, performance comparison methods of the classifiers. We use lift chart. Lift charts are used to evaluate classification models with binary target variable. While evaluating a model, there are so many metrics that we can use like accuracy, precision, recall, RSI curve, etc. Some of the metrics can be misleading too. For example, if you use accuracy metrics in data where target rate is 2%, the population proportion of one of the classes is low, the data is the data is unbalanced, then you might get 98% accuracy in your model even though all the points in one of the classes are classified completely wrong. Metrics like precision, recall, F1 score, etc. can provide an idea on how the model is performing. However, they do not provide deeper insights on the performance. Lift charts can provide further details like rank ordering. I don't know myself very well about rank ordering in probability score and relative ability of the model compared to random classifier. So we develop lift chart in when we need to compare the classification models. How to build a lift chart? Calculate the probability of each of the observations, sort the data based on predicted probability in descending order. Group the data based on population. Typically, they are grouped into deciles, that is, into 10 groups. Get the max and mean probability of each of the deciles. Calculate the population percentages, cumulative percentage of events, and cumulative percentage of events on each side of the deciles. Cumulative percentage of events is also called the gain percentage. Calculate lift by dividing the gain percentage with cumulative population percentage. Let us consider a use case. Let us consider the very famous Titanic dataset from Kaggle as an example. We have 891 samples in the training dataset, and for now, let's forget about the test dataset since we need actual Y to evaluate the performance. In the data, we have X variables such as age, their coach classes, sex, ticket fare, etc. While the training data, we build a model to predict which passenger is more likely to survive. The model assigns probability between 0 to 1, the survival probability. Three models, logistic regressions, SVM, and random forest classifier, are built on the same data to show the comparison between the models' lift chart so that you will be able to understand its importance better. So let's start with gain chart first. We have logistic regression, random forest, SVM, and the random model, the coin toss probability, and and these are the graphs for different classifier. Gain chart will provide an idea about which model is performing better and which segment to choose and how many segments to target. Let us assume we have lifeboats that can save up to 270 passengers. We have to pick only those with the maximum probability of survival. That is when the gain chart helps. It helps to target specific passengers whose probability of survival is more. About the lift chart, these are again three classifiers: logistic regression, random forest, and SVM. Logistic regression gives a lift of 2.61 over the random model, which is considered to be 1. And we are getting the maximum lift in case of random forest model. So that's the way we compare the performance of the classifiers. The lift chart basically shows how likely a passenger would survive if we pick a passenger in a random manner. Here the lift in the first decile is 1, 2.02, 2.54, 2.61 for random model. So Lifts are 1, 2.0 to 2.54 and 2.61. For random model, SVM, logistic regression, and random forest classifiers respectively. It means that the random forest model captures survivors among the passengers 2.61 times better than random. Some endnotes, like every other metric, lift charts are not a one-off solution, but they help in evaluating the overall performance of the model. One can quickly spot the flaws in the model if the slope of the chart is not monotonic. It also helps to set a threshold to choose the segments that are worth targeting much better than the random target. I'll stop here. The entire talk is based on an article from Medium. Like, comment, share, subscribe my videos. I'm available for one-to-one solution too. Thank you.